I'm going to tell you that this problem is a challenging problem. And I want to, in order to really work the problem, since a salt is not added to this problem, I'm going to have to show you how to find the mean using a formula. So I'm going to take some time and talk about the formula. And then I'm going to show you how to find the median, procedure for finding the median, rather than using a stack pack like so. Then from there, I will try to lead you through the problem. There's two challenging problems on this assignment. 7 and 10 are challenging. But if you look at courses at the same level that this course is in statistics, you'll find these problems are quite prevalent, and they're used and they're solved and expected students to know how to solve them. So let's get about doing it. First of all, if you were to look up on the internet, put in the word, do a search for mean, you would find that in almost every one of the particular YouTube or whatever is showing it, Khan Academy or whatever, that they will give the formula in terms of mathematics. And I want to give that to you and share that with you today. And you need to know it anyway. So we'll take a little time and work this problem. First of all, out longhand, and find the median longhand and the mean longhand, okay? So, I've copied, in problem 7, I've copied the values down. Maybe we ought to look at those values before we go any further. Okay. Let's look at problem 7 before we start, so we know what we're talking about. In problem 7, we're given 4 pieces of luggage, and we're given the pounds at each piece. 4 pieces of luggage are. So the first piece of luggage weighs 33.3 pounds, second 27.2, third 36.6, and fourth 30.9. So these are the pieces of luggage we have. We have raw data, and the number of items in the raw data are 4. So it's fairly easy to find the average or the mean. The median, you can't find, just by looking, you can't find the center of the data. So we'll have to show you a technique on finding the median. But anyway, I want you to notice that X bar equals sample . You got a mistake there. X bar is the sample mean. In mathematics, if you see X with a bar above it, it represents sample mean. Oh, I see what it says. Find all possible values. He wants to add one more piece of luggage, okay, to the raw data set in such a way that the mean, which is X bar, equals the sample median. We want it 0 skewed, in other words. And we want to pick the X sub 5 in such a way that the mean, sample mean, will equal the sample median. That's what we're set out to do. But before we get started, let's find the mean, or the average of this data set, and we'll find the median. And that'll allow me to talk a little bit about the mathematical formula involved, okay? Now, so what I'm going to do, we're going to stop the share here and go to a document camera, and I've written these weights down, okay? The first thing I think I want to do is reorganize, order the weights from smallest to largest, okay? To find the median, you have to do that. So let's just do that up front. I think the smallest is 27.2, so I'll let that be my X1. Then the next is 30.9, and I'll let that be my X2. So let's write that down. I'm going to reorder this. X1 is going to be equal to the smallest, which is 27.2. X sub 2 is the next to the smallest, which is equal to 30.9. And X sub 3 is equal to 33.3. And X sub 4 is equal to 36.6. Now these subscripts just indicate X1 is different than X sub 2, is different than X sub 3, is different than X sub 4. They're just subscripts, okay? Ways of defining. Okay, so now we have that. Okay. If I put a pencil in there, my document camera is focused better. Okay, now, if you look on the internet, here's the formula for the mean. X bar, that's how we represent mean. And I'm going to say sub 4 because we're going to talk about the mean of a raw data set of 4 elements and the mean of a raw data set of 5 elements. So that's going to equal, and we borrow from mathematics a symbol called sigma, which is a Greek letter, and it looks like this. And when you see this in mathematics, that indicates add up whatever's in here. And we indicate, I like to write down how far this, where it starts. So this I is just a dummy variable called an index. I going from 1 to 4 in this case. In general, we would put in, but 1 to 4 in this case, of X sub I, all divided by the number we have, which is 4. Now you'll see my madness as we go along, but using these symbols helps us to understand this particular problem. What this says is take X sub I and let I vary from 1 to 4 and add them up. In other words, when I is 1, we have X sub 1, and the summation says add up. X, when I is 2, we have X sub 2. I is 3 is X sub 3 plus X sub 4. That's what that means. All divided by 4. Now that's what that means symbolically. Okay. And knowing this definition, now usually we have X bar sub n over n, and we go from I going from 1 to n, where n can be any positive integer. Okay. So we could have 27, or n could be 27. We would go from I for 1 to 27, and we have 27 of these things out here divided by 27. and is equal to 27. So you see, in general, how this reversed. So in symbols, we have x1 is 27.2 plus x sub 2, which is 30.9 plus x sub 3, which is 33.3 plus x sub 4, which is 36.6, and that's all divided by 4. So let's see what we have. You have a trusty calculator. You can put this out on very quickly on the calculator. I just happen to have one. Now, we've got 27 point 27.2 plus 30.9 plus 33.3 plus 36.6, and we add those. Oh boy. So did I enter one of those wrong? Yes, I did. Got too many points. I'll put them in again. I'm sorry. 27.2 plus 30.9 plus 33.3 plus 36.6. Now, we have 128 divided by 4, which gives us 32. So the mean is 32. Okay? The mean of this raw data set, which has 4 elements in it. Okay? Now, how do we find the median? Well, to find the median, if we write the elements in order from smallest to largest, we did that. I'm just going to copy it down again so you can see it. What we do, write it in from smallest to largest. And I like to do this. Just start counts, just put a line through here, the smallest and the largest, and keep doing that until you get down to either 2 elements or 1 element. In this case, we have 2 elements. So what we'll do is we'll take these 2 center elements together, add them together, and divide by 2. We'll find their average. So we have 30.9 plus 33.3 divided by 2. Okay. And if we do that on the calculator, we have 30.9 plus 33.3. And we come out with 64.2 divided by 2 which is equal to $32.1. Okay. Now, this is a technique on how to find the median, technique on how to find the mean volume. Okay. Now, let me say this, that if we look up here in this raw data set, 32.1 is the median, all right? It's not part of the data set. If we had only one element in here instead of two when we did this canceling, then we would have just one element, and it would be a member of the data set. But this is not a member of the data set. Now, listen to me. This can be proven mathematically. If we let the mean of our new raw data set, that's adding x sub 5, which is another luggage to what we already have, and coming up with another data set, if we let the mean be equal to this number and solve for x sub 5, then the mean of our new data set with x sub 5 added in will be equal to the mean, will be equal to the median of the new data set. Also, if you let x sub 5 bar equal to that and solve for that, the resulting raw data set will be a data set in which has zero skew, where the mean is equal to the median. Also, if we let, that's one situation, if we let the mean of our new data set, remember, we don't know what x5 is, but if we do add x5, and we let that mean equal to the raw data set of 4, the one directly to the value directly to the left, and the value directly to the right, it'll also produce a zero skewed raw data set. So we'll take the first case, we'll take it equal to the mean. Excuse me. The mean, which is 32. We let it equal to 30.9 and solve for x sub 5. It'll also give us a raw data set where the mean and the median will be equal. And the third is x bar sub 5 equal to the other number of the raw data set for the original, for just to the right of the median, in this case 33.3, and we'll solve for x sub 5. So we'll have three values that'll produce an x sub 5. They'll result in a raw data set where the mean of that raw data set is equal to the median of the raw data set. To prove that this is a situation mathematically is probably a little bit more than what this course is thinking of some algebra that probably don't need to know for right now. But anyway, that's what's behind the problem. So the first thing we'll do is we'll take x bar sub 5 equal to 32, and we'll solve for x sub 5. I'm going to do that on another document camera so we can keep this here so we can refer back to it. Okay. By definition, we have x bar 5 equal to the summation five going from 1 to 5 of x sub 5 all over 5. Okay? I'm going to write this a little different. I'm going to write this as the summation as I goes from 1 to 4, because we have it already, and we know what x sub i's are for that, plus x sub 5 all over 5. Now you've seen this before, so I'm just breaking it up. I'm just going to go from 1 to 4 and pull the fifth one off like this, because I'm going to solve algebraically for x sub 5. Okay? So far, so good. We don't know what x bar sub 5 is. So what we said, we're going to let x bar 5 equal to the mean of the raw data set that has 4 atoms in it, which is equal to 32. So that's the first thing we do. Okay? And if we substitute that in, we have 32 is equal to the summation of I going from 1 to 4 of x sub I plus x sub 5 all over 5. Okay? Now, let's multiply both sides of this, because we solve x sub 5. Multiply this by 5 and this by 5. Or you can even say closing up the other side. And this to divide out. And I'll have 5 times 32, which is 160, isn't it? Let's see. And 32, and it's 160. So I have 160 is equal to the summation. I'm going from 1 to 4 of x sub I plus x sub I. Now, if I knew what the summation was from 1 to 4 of x sub I, then we can substitute that in and solve for x sub I, because I could add that to both sides, and that would give me what x sub I should be. But you know this. We're going to add those together. In fact, we did. We added them together and got 64.2. No, when we added them together, we got, well, we didn't write them down. So let's just add them together. This is just the elements that we already have. And we have 33.3 plus 27.2 plus 36.6 plus 30.9. Okay. It was 128. So we have here 160 is equal to 128. That's just adding the four numbers together plus x sub 5. So if I subtract, doesn't break me solve for x sub 5, we have this, and we have x sub 5 is equal to 160 minus 128. We have we'll check something here. We have x sub 5 is equal to 32. So if we take x sub 5 equal to 32, we're assured that the resulting distribution of the four luggages that we have, plus the new luggage, which is 32, we know that is going to come out to be our zero skewed. And you can check it out, zero skewed distribution. Okay. Now I'm going to do the one more, and then I'm going to let you do the last. Okay. I'll do the same. Definition. X bar 5 is equal to the summation as I goes from 1 to 5 x sub I plus, and that's it. Okay. That's what the definition for the unit is for the 5. Now, I'll rewrite this summation as I goes from 1 to 4 of x sub I, because we know what that is. We just found out that's 128. So we know what this is, right? Because we know that the one values just to the left of the median of above that is set for 4 items. So that's plus x sub 5 all over 5. So we're going to let x bar 5, we're going to let that equal, and if we went back to our other locking the camera. We'll let x bar 5 equal 30.9. So we'll go 30.9. And we'll put everything in that we know. So we know we have 30.9 is equal to 128. That's when we add the 4 up, plus x sub 5 divided by 5. So we'll multiply this side by 5 and this side by 5. And the 5's over here will cancel out. And give you 30.9 times 5, which is equal to 154.5. And that's equal to 128 plus x sub 5. And if we subtract 128 from both sides, we have x sub 5 is equal to 26. So this goes out to be 26.5. Now, the last one, you'll let x bar 5 equal the last value, which was 33.3. 33.3. Now, let me go from this camera to the other camera. This is letting x bar 5 equal 30.9. And I just solve for x5. I'm putting 30.9 in here for x bar 5 and 128 in here for this sum, because that's the sum of the raw data items for the 4 pieces of luggage. Put that in there and solve for x5. And when I do, I have x5. When I solve for that, it comes out to be 26.5 equals x5. Now, I'll leave this up here for a few minutes, so if you want to copy your notes, that's how we got that done. Okay. Now I'm going to let you do the last one. It's done the same way. We'll take x bar 5 equal to 33.3 and substitute it in here, 33.3. And we'll substitute in for the summation of I going from 1 to 4 of X of I, which is 128. So the only thing that's different in what you saw is rather than a 30.9, you're going to put in 33.9 and solve for X5. So it's very simply done. Okay. I'm going to leave it that and let you do the last piece, okay? That'll give you the three values of X bar 5, so that when I add it to the raw data that was given for the 4 pieces of luggage, the new raw data set will have a distribution with zeros cubed. The mean will equal the mean. Okay.